Okay, so here's another example of a telescoping series. Telescoping series are characteristic of this, uh, where you have expressions like k plus 1, uh, and k plus 2, k plus 3, that we're dealing with those kind of things as k goes from 1 to infinity. That's kind of the characteristic you're looking for with the telescoping series. It's a difference of two fractions uh, where the pieces involve uh, k plus something. Okay, and because k is going from 1 to infinity, you're actually going to take on a lot of values. And when you have a difference like this, a lot of things will end up, kind of disappearing. Okay, so let's start to expand this one a little bit. Look at the first few terms, so we can start to get a feeling for how things are going to cancel out. How things are going to cancel out. Okay, so first term, k equals 1. This would be 1 over square root of 2 minus k equals 1. This would be 1 over the square root of 4. Okay, the next term, k equals 2. This would be 1 over the square root of 3 minus 1 over the square root of 5. And keep going, plus 1 over k equals 3 now, so that would be 1 over the square root of 4 minus 1 over the square root of 6. And keep going, plus 1 over the square root of 5 minus 1 over the square root of 7, and this continues on here. So now I'm going to come up to n now. But what I realize here is that for the cancellation, it starts happening not with the very next one, like the last problem, but with one that's 2 ahead. Okay, and then same thing, the square root of 5 cancels with the one that's 2 after it. And then the square root of 6 would cancel with the next one. The square root of 7 would cancel with one that's 2 after that, and so on. And so with that in mind, I need to actually think back a couple of terms. Okay, I need to go back a couple of terms. So the last term would be n, but the stuff with n is going to cancel from 2 steps previous. So when I write out my terms for n, I'm actually going to start with 2 terms before n, so we can see how everything works. So in other words, I would actually be plugging in n minus 2. So that's going to be 1 over the square root of n minus 1 minus, and then n is equal to n minus, we're putting n minus 2 in. So n minus 2 plus 3 would be 1 over the square root of n plus 1. Right. Plus, now n minus 1. n minus 1 plus 1 would be 1 over the square root of n. Minus 1 over the square root of n plus 2, and then finally we're equal to n. That would be 1 over the square root of n plus 1 minus 1 over the square root of n plus 3. Okay, so I wanted these extra terms so I can see that very clearly this 1 over this term here, 1 over square root of n plus 1, is getting canceled out. And likewise, this 1 over square root of n, this 1 over square root, get the right one, 1 over square root of n also would have been canceled out. Right? That would have happened with the previous term. And that one would have happened with the 2 that's previous of that. So, but the 1 over square root of n plus 2 wouldn't cancel until we get to the next term. And this one wouldn't cancel until we got 2 more terms up there. So this time, of course, the square root of 6 stuff is going to cancel out, right? And we know the square root of 7, I'm starting to run out of colors here, right? That's all going to cancel out. So the stuff that's left now here is this. Sn, the nth sum, would be 1 over square root of 2 plus 1 over square root of 3 minus 1 over the square root of n plus 2 minus 1 over the square root of n plus 3. Right? And then we would take the limit as n goes to infinity of our sum. And of course, those two terms, as n goes to infinity, they're just going to go to 0. So it turns out the limit of this sequence is 1 over the square root of 2 plus 1 over the square root of 3. Okay, 1 over the square root of 2 plus 1 over the square root of 3. Okay. So it's not some nice number, but it is a number. And you can look at this on a calculator here. If we went out, the actual value, 1 over square root of 2 plus 1 over the square root of 3. So there's our decimal answer there. 1.28445 and so on. And we can put this Sn formula into our graphing calculator and again look at the table to see how the terms are starting to eventually converge to that. Okay, we're going to start to eventually converge to that. Okay.